Hello everyone, so today we're starting a new unit. We are going to be talking about gas laws. So on this first page, make sure you put your name on it, all that good stuff. And now let's look at our table of contents. See if I can zoom in a little bit so you can see. So tomorrow for you all, but Thursday, the 12th, you will be doing Boyle's Law and Charles' Law. On Friday, you will complete Gay-Lussac's law and the combined gas law. On Monday, you will do the kinetic molecular theory / STP and the ideal gas law. Tuesday will be the lab, and then your test will be on Wednesday. So this unit is short and sweet, and hopefully fairly easy for you guys. So since this is called gas laws, this whole time we will be talking about gases. So on this first page, and you'll notice on the notes section, if there's a formula, I have the formula itself written down for you. So when we talk about that, I'll go over it and mention it, but I already have that part typed out for you. So for Boyle's law, your topic is of course Boyle's law, and your goal is I can solve problems that involve the pressure and volume of gases. Now again, with watching videos, I'm going to present this, make it a little bit bigger for you all. When watching videos, you can of course pause whenever you need to type out what you need. You need the topic and goal in the topic and goal box, of course, but for the notes section, if it's underlined, you need it, and if it's red, you need to highlight it or underline it, because that will be a vocabulary word. So some characteristics of gases that you need to know. You need to know that gases expand to fill any container, and that's because there's random motion, there's no attraction, they just kind of fill the room. Gases are fluids, like liquids, which means they take shape of whatever container they're in, and that is also because there's no attraction. Gases have very low densities, which means they float, and that's because there's no volume or there's lots of empty space. So here you have the particle arrangement. This first box right here looks like a solid because they're close, compact. The liquid, there's a little bit more space, but they're still connecting, whereas gases are all spread out and fill up the entire area. You also need to know gases can be compressed. This is how you get like a can of helium, or like your propane gas is in a tank, so it can be condensed into a container because there's lots of empty space. They also undergo diffusion and effusion because of the random motion. So if I were to spray air freshener on a far corner of the room, people on the other side of the room is not going to smell that air freshener at first. But eventually that smell or that spray will travel throughout the whole room and you will get a little smell of it. It just doesn't happen instantly, and that is an example of diffusion. Okay, temperature. Always use the absolute temperature, which is Kelvin, when working with gases. This number is a fairly large number, and it makes the math easier. It makes it to where your number isn't going to be huge decimals. It makes slight changes easier to manage. So every single problem, which I will try to drill this in your head, is you have to use Kelvin. Now, in order to use Kelvin, so Fahrenheit is what we use for temperature. Chemistry, we do not use Fahrenheit at all. So far in this class, we have used Celsius. Well, Kelvin is very similar to Celsius. It just kind of helps keep from the numbers being negatives and having to change signs and all that good stuff. So it makes it a little bit easier for us. So what you don't need to worry about this formula because we're not using Fahrenheit. You just need to know this one. K equals the degrees Celsius plus 273. So K equals the degrees Celsius plus 273. If I have 32 degrees Celsius, what is K? So what you would do is you would take 32 plus 273. Grab my calculator. So 32 plus 273, that would be 305 Kelvin. That would be your answer. Okay, if I have 100 degrees Celsius, what is that in K? So you would do 100 plus 273 is 373. So it's super easy to go from Celsius to Kelvin. You just have to add 273. Pressure. So pressure is your force over area. So we have these shoes. Which shoes creates the most pressure? Well, that would be the high heels because this heel has a very small area. So since it has such a small area, there's going to be a much higher force going down on that, so it would have the highest pressure. Now, which one would have the lowest pressure? Well, the way you could check that is it'd be the one with the biggest area, so it'd be these snowshoes. That's why people use snowshoes. If there's a lot of snow, that snowshoe keeps it from having all this pressure, so you kind of just stand on top of the snow instead of sinking through the snow. Okay, you need to know a barometer measures atmospheric pressure. They use this to help kind of identify like storms coming through. Here are two pictures of barometers, some examples. There's a mercury barometer, and then there is a aneroid barometer. You need to know a manometer measures contained gas pressure. So this is like those little PSI readers that you see in your tires or on your propane tank. Those are manometers because it's measuring contained gas pressure, which the burden tube gauge is typically what we see on most tanks and stuff like that. So key units at sea level. There are a lot of units of pressure. The one we will be using most of the time is ATM. And atmospheric pressure, oh, that's what ATM stands for. It's atmospheric pressure. Now, the pressure of the air in a given day, if you were to walk outside, the pressure tends to be about 1 ATM, just in general. So there's also kPa, which is kilopascals. There's millimeters of mercury, torr, and psi. Psi is probably another one that you're very familiar with. Most of our questions will be ATM because atmospheric pressure. So if you see the unit ATM, you need to know that is talking about pressure. So that's why I want you to write that down. Key unit at sea level, 1 ATM. So now we're going to start talking about the gas laws themselves. There are three individual ones, Boyle's, Charles, and Gay-Lussac's. Then we have the combined, where you combine all three of them. And then we have ideal, which we'll get to eventually. So Boyle's law. Let's look at this chart. Here in our volume column, it's increasing. It's going 10, 20, 30, 40. What's happening to our pressure? It goes 760, 379, 253. It's going down. So since our volume's going up, our pressure's going down. Well, if we draw that on a chart, as the volume goes up, the pressure goes down. Well, using that gives us the definition for Boyle's law, which says that the pressure and volume of a gas are inversely related, which means what happens to one, the opposite happens to the other. So if our pressure goes up, our volume goes down. If our volume goes up, our pressure goes down. And knowing this information gives us this formula, which I already have in a picture in your notes section for you, but it's P1V1 equals P2V2. P stands for pressure, V stands for volume. Our pressure is typically ATM, that's our unit. Hold on.
Jasmine O'Hare, come to the office, please. Jasmine O'Hare.
And our volume is typically liters or milliliters. So an example we're going to work through together. If I start with 5 liters in a balloon with a pressure of 2 atm, Change the pressure to 1 atm, and what is my new volume? So when doing these questions, and yes, I want you to write out this example in your notes so you do have an example to help you with the practice. The first thing I do is I list what's given to us. So we know our first volume is 5 liters. We know our first pressure is 2 atm. So, and then change the pressure, so our P2 is 1 atm, and we are looking for V2, so that equals question mark. So we need to plug that in our formula. So here, P1, V1, so P1 times V1, so 2, let me find the star button, times 5 equals P2 times V2, so 1 times X, 1 times X. So we need to solve for X. Well, 2 times 5 is 10 equals 1X. So since 1 is being multiplied, you would do the opposite of that, which is divide, which is just 1. So our V2 equals 10, and it would be whatever unit your first V1 was. So in this case, it's just liters, so 10 liters. All right, in your digital notebook, you have 4 problems to work on. I did put the charge up here for you. You are welcome to work these out on paper, and you can just send me a picture if you're virtual, or you could turn in the paper itself um, if you're in person. If you have any questions, or if you just want me to check your work, I will be happy to. You just got to let me know, and I'll show you how we can do that. And I hope you have a great day.